In this video, we are covering the essential formulas of differentiation you need to know to master calculus. First, we look at the power rule, which tells us that the derivative of x to the power of n is calculated by bringing the power n to the front and multiplying it by x to the power of n minus 1. Next is the constant rule, which states that the derivative of any constant value like a fixed number is simply 0, because constants do not change. If you have a constant multiplied by a function, the rule is easy. You just take the constant out, differentiate the function itself, and then multiply them back together. Moving on to exponential functions, these are highly unique in calculus. The derivative of e to the power of x remains exactly e to the power of x, meaning it does not change at all. Similarly, when we differentiate a general exponential function like a to the power of x, the result is a to the power of x multiplied by the natural log of a. For logarithms, the derivative of log base e of x, which we also know as the natural log, is simply 1 over x. If the logarithm has a different base, like log base a of x, its derivative becomes log base a of e divided by x. Next, let us look at the standard trigonometric functions, which follow a very specific, alternating pattern. The derivative of sine x gives us cosine x, while the derivative of cosine x introduces a negative sign, becoming negative sine x. The derivative of tangent x becomes secant squared x, while its counterpart, cotangent x, gives us negative cosecant squared x. Similarly, the derivative of secant x is secant x times tangent x, and differentiating cosecant x results in negative cosecant x times cotangent x. Notice how every trigonometric function starting with co always gives a negative derivative. Finally, we have the core algebraic rules for combining different functions together. For addition and subtraction, the rule is straightforward. You just differentiate each function individually and keep the sign the same. For multiplying two functions, we use the product rule, which is the first function times the derivative of the second function, plus the second function times the derivative of the first function. For dividing functions, we apply the quotient rule, which states that the derivative is the bottom function times the derivative of the top, minus the top function times the derivative of the bottom, all completely divided by the bottom function squared. Learning these basic building blocks thoroughly will make solving even the most advanced calculus problems look incredibly easy.